Hi there, guys. Today we're going to be talking about memory engineering, context engineering, and prompt engineering, and how they all fit within the context of AI agents in making them reliable, believable, and capable. There's a lot of talk around context engineering and prompt engineering. We're going to be looking at memory engineering and how each of these engineering disciplines build on top of each other. We're going to be looking at most of this in code. For those of you that want to skip some of the slides or the theory, or you already know what agent memory is, you can skip to the code part of this. But for those of you who want to have an understanding of what agent memory is and what context engineering and memory engineering is and how they differ, stick around. We are going to actually get really deep within this topic. First thing we have to talk about when we talk about AI agents is the agent stack. The agent stack is a composition of different tools, infrastructure components, libraries, and all the things we actually use to make agents actually work in production. They're different parts of the stack, but today we are going to focus on the reasoning part. This is the LLM, and we're going to introduce a layer of the stack called memory managers. These are specifically an area of building agents that is responsible for the movement of information and data from the context window into an external memory store. And there's a bunch of engineering that goes into the memory managers' responsibilities. For some of you that have used libraries like Mem0, Zep, or Letter, or MemGPT, you will call these tools memory managers. We're also going to be talking about the tooling area as well. We are going to talk about the memory core. What does a memory core mean? What does it mean within the infrastructure of your actual agent stack? And we're going to look at the Oracle AI database as the memory core of our agent. So there are two things you're going to get from this video. You're going to have an understanding of prompt, context, and memory engineering and how they work together to build AI agents. And you're also going to get an overview of agent memory, a topic that's going to keep growing in popularity. First, we have to talk about what is context engineering. For us to understand context engineering, we have to talk about prompt engineering. This is an example of a prompt. Can you recommend some good holiday destinations for the summer? A prompt is an instruction or a piece of text that you pass into an LLM. Whenever you interact with ChatGPT, that would be some form of prompt to the system. The key thing is we understand what a prompt is. It could be a sentence, it could be a phrase, but the engineering aspect of prompting is actually quite robust, and there are a few techniques. Some popular ones are few-shot prompting, chain of thought prompting, and there's also React prompting. There are papers and articles on these prompt engineering techniques, but few-shot prompting is actually quite simple. Few-shot prompting is when you give the LLM examples of how you would like to respond. LLMs have this capability of in-context learning, so they can actually learn from content that we pass as context into the LLM itself. For example, if I want an LLM to be able to recommend some holidays and I want it to respond in a certain format, I can give it an example of the format I want it to respond, which here is the question and answer format. So I give it an example one of question answer. Next, whenever it sees a question, the LLM will learn to provide an answer in this specific format. So that's few-shot prompting using that in-context learning capabilities of LLMs. The next one is chain of thought prompting. The reason why you would do this is to let the LLM see its reasoning steps as well, or think step by step about a certain problem before coming up to an answer. This is trying to surface up that latent reasoning capabilities within large language models. For example, here you can see we have a question, and to surface up this reasoning in my prompting, you would give it examples of how it should break down the question and think about the question, which in this case is the recommendation of a holiday. But I'm giving it an approach where we're telling the LLM to think step by step, and I'm showing it how it can actually think step by step, and then it'll mimic this process. Then the last one is React prompting, where an LLM is able to reason about an observation and then take a certain action. All these techniques are prompt engineering techniques. They maximize the amount of tokens we're passing into the LLM. So prompt engineering is a maximization technique. Whenever you use prompt engineering techniques, you're going to find that you have robust prompts and you're passing these into the context window of the LLM. The thing about prompt engineering is we don't need it as much as we used to, maybe about 2 or even a year ago, because these LLMs are actually quite large in terms of the weights and the parameters within the LLM itself. And as we increase the scale of these LLMs in terms of data, compute, and parameters, we see emergent abilities such as reasoning capabilities. And I've seen as the reasoning capabilities of an LLM increases, the less prompt engineering and more instruction tuning we have to do to make sure that the LLM is following the behavior we expect. So prompt engineering is using a bunch of words, phrases, linguistic patterns to actually make sure that the LLM is actually conforming to expected behavior. Now we can talk about context engineering, because we spoke about large language models having reasoning capabilities, which means we can reduce the amount of prompts that we provide to the LLM. This allows us to think carefully about the context itself that we're passing into the LLM. What is context engineering? Remember, this is a prompt, right? Can you recommend some good destination holiday? And you can put that in an LLM. Context is all the information that is used to provide background information, scenario information, problem domain information, so that the LLM can actually use that context to better answer a user query. Context is additional information related to the actual user query or prompt. Anthropic put out this very good piece called Context Engineering for AI Agents, and they actually show the difference between prompt engineering and context engineering. You can see here that context engineering, you're putting in more information into the context window of the LLM itself. You're putting in the system prompt, a user message, a bunch of documents, memory file, and message history, so that this LLM will be able to provide a more relevant output related to the user message. Anthropic defined what context engineering is best, in my opinion. They've captured this movement or evolution from the engineering we're doing within agents. It's less about finding the right words for your prompts, but it's more about figuring out what configuration of context is likely to generate our model's desired behavior. Configuration of context means that there is some form of arrangement. So to configure context, we have to go into some engineering techniques. The way I'm able to understand context engineering is by looking at common context engineering techniques and creating what looks like a flywheel. Job of context engineering is to maximize the signal per token, right? So every token is very useful to actually answering the objective and making sure that the output of the LLM is optimal and expected. There is context window utility. In this context engineering technique, you might find techniques such as monitoring the context window and giving the LLM some form of information as to the context window utilization, using techniques like triggering summarization once you pass the context window threshold. Then there is context organization. Intelligence requires some form of structure, right? We can see that Anthropic has this structure. I don't know if they're presenting it as this defined structure of what goes into the context window, but there is some form of structure and organization of information that we're putting into the context window. Then there is context isolation and composition, context retrieval, context reduction, and context offloading. We're going to be seeing all of these techniques in the code section of this video. This is the key takeaway. Context engineering is optimization. If you remember, prompt engineering is maximization, increasing the amount of token we pass into the context window of the LLM to be able to get our desired output. Now, context engineering is making sure we're passing in the right token and each token is optimal, and we actually have a high signal to noise ratio for content within the context window of the LLM. So context engineering is an optimization technique. Then we can talk about memory engineering. To talk about memory engineering, we have to look to ourselves, humans. Humans have, in some way, one of the most advanced memory capability of organisms on Earth. There are different types of memory in humans. We have short-term, long-term, episodic, associative, implicit, explicit memory. In fact, human memory is so complex, it's still an active area of research today, but we can draw inspiration from human memory and bring it into the agentic context and actually start to create computational form of the memory types that we understand humans to have. When people ask, what is agent memory? Agent memory is this systematic process of moving information through the components of an agentic system, moving information from the embedding model into an external memory store like a database, into the context window of an LLM, into this parametric memory that actually doesn't change the LLM itself. Those are components of an agent, and from a memory perspective, an agent memory encapsulate this, and on top of this is a memory management system that can encode, store, and retrieve data. The objective of implementing agent memory techniques is to make AI agents more reliable, believable, and capable. There are different types of agent memory. So there is short-term, long-term, which are the clear distinction. Short-term, it can live within the session, and long-term lives outside the session. The lifespan of the information extends beyond the session. The session is a current interaction between an LLM and the user, form of boundary usually defined by time or some form of interaction length. There are different types of short-term and long-term memory. This diagram shows it, but in the code section, we're going to go into some of this in detail. The key thing here is memory engineering, right? We know what agent memory is, and we know we need to engineer it. Memory engineering is all the scaffolding AI engineers have to build into the agentic system to move data from the embedded model to the database, to the context window, and then back again. The aim is to make sure that we have our AI agents more reliable, believable, and capable. That's what memory engineering is. In my perspective, it is the job to be done. Just like with prompt engineering, as we saw more emergent capabilities of LLMs, and that led to the reduction of prompt engineering techniques, I think we're going to see that with context engineering. As the LLMs get bigger, they actually start to have more extended reasoning capabilities and show even some form of abilities that we can't even think of today. We will now focus on the optimization of the memory system, the retrieval system that we have. We're going to focus on the information within each memory unit that we keep passing into the system, into the context window, and out again. This movement of data from the database into the context window, then back out again. What we see is memory engineering is actually this continuation engineering technique, where what the aim is we want our agents to continually learn from information given to it or information sees within its environment. So memory engineering is a continuation technique. And just to summarize, prompt engineering is maximization. We're focused on putting as much token into the context window. Engineering is optimization, where we're making sure there is a high signal for each of the tokens. Each token that goes into the context window, we make sure it's augmented with more information that can allow the LLM to remember information. Each token that comes out from the context window, we make sure that we have this engineering harness and scaffolding to enrich it with some information, maybe to structure it efficiently and store that within an external store so that it can be fed in again into the context window of the LLM at an appropriate time when it retrieved based on a certain prompt or an objective. So memory engineering is continuation. I was going to talk about this diagram before we get into the code. I'm going to talk about it before we get into some information. But just very quickly, AI engineers are working with essentially three type of information, data, primitive, whatever you want to call it. We have the prompt, the context, and memory. If you understand that there are engineering disciplines that go into each of this classification of information that we pass into the LLM, then you start to understand the evolution that is actually occurring when we get into the code. So let's look more into that diagram. In this diagram, I was trying to communicate where context engineering stops and memory engineering begins. I was able to understand that memory engineering is all the engineering techniques on the boundary of the memory core. The memory core in this case is the Oracle AI database. The memory core essentially is able to handle different data type that you expect in your AI workload, give you different ingestion methodologies and patterns and embedding generation, and also provide you with tools that allow you to optimize retrieval, indexing, and advanced techniques like quantization. This is what a memory core is. Then within a memory core and the context window, you might have something that looks like a memory manager. Now, memory manager is just a bunch of code that basically takes an information and then transforms or acts on the information in a way that improves the ability for that information to be recalled, or in some cases, modify the chances of that information. We do have to have some form of forgetting mechanism within memory or some form of decay logic. There are a bunch of memory managers and libraries out there. Popular ones are like Supermemory, Mem0, Letter, LangMem from the LangChain team. Most of them have this concept, which is taking in information, acting on the information to improve the recall of that information and to make the agent or the LLM remember certain information effectively. A memory manager can also take information from the context window, refine it. If I was to zoom in here, we can refine the information and we can augment the information as well, and then pass it into our memory core for storage. Within the memory core, you have the capabilities to actually model different type of memory types, which we're going to see this in code. This is me thinking about, okay, what do we see? How does data move? What are the key components of a agentic system that embody context, prompt, and memory engineering practice? For prompt engineering, you can see it over here. With prompt engineering, you're usually having it get involved or modify some of the components of the context window. All the code I'm going to share in this video is available in the link in the description. It's also available in the Oracle AI Developer Hub repository, which contains a lot of code. You can see this memory and engineering agents notebook, which is what we're going to go through.